fairly confident you don't have the zero difference, that they're the same. Good job. So here, feel free to even do that on any problem, add that. Like you said, it's just further evidence. All right, well, this is number 22. Views on the death penalty. Oh gosh. Don't even know these two groups are, this is hilarious. Group 1, everyone. This is number 20. 2. Death penalty? Pew Research did this. Did they give a year? No. Are you in favor of or opposed to executing persons as a general policy when the crime was committed while under the age of 18? Let me repeat that. Pew Research Group conducted a poll in which they asked, are you in favor of or opposed to executing persons as a general policy when the crime was committed while under the age of 18? And this is for capital punishment. Group 1, Catholics. Who's group 2? Seculars. So when this was Catholics, these are secular. All right, let's see what we get. In group 1, 180 in favor of capital punishment. 180 out of 580. So not normal. In favor of capital punishment. What about group 2? How many in favor of capital punishment? 238 of 600. 238 out of 600 in group 2. This is P hat 2. These are the seculars. In favor of capital punishment. All right. Let me read the last question. Is it going to be left tail or right tail? What are they trying to test here? Is there a significant difference in the proportion of individuals in these groups in favor of capital punishment? Let me read that again. That didn't say less than or greater than, did it?
Difference.
Difference. Listen, let me repeat this. So I'm going to set my mouth and go, is there a significant difference in the proportion of individuals? So that means two-tailed test, doesn't it?
Mm-hmm.
They didn't say, is Catholics greater, is the seculars less than group 1, group 2, or anything like that being less than or greater than. It says a difference. So when we set this up, we know what the null is. Proportions equal, but what's all our alternative hypothesis? Not a two-tailed test. All right, we'll verify the requirements, but we want to just get to this. If I shade two sides, I'll see what the alpha level is. You know, got a two-tailed test. Like I said, I mean, we won't write everything out, but at least we can put some notes down. We're going to look at the p-value. You got that? What's the level of significance? Do you notice a lot of times they use 5%? A lot of times they use 5%. This time it's 1%. And here's your level of significance. It's 1%. It's a 1% level significance. But it's two tails. So how much is in this tail?
Divided by 2. Alpha over
Can
alpha.
somebody do that in their head, or somebody do it mentally? What's this? Level significance divided by 2. 0, 0. I'm going to write that. Everyone. There's your, it's not a z-score. That's my alpha on this side. They call it alpha divide 2. You've probably seen that in the book. I'll get that z-crit. Here's an alpha divide 2 of 0.005 on this side. All I did was take that 1% and divide 2. But I want to see what my crits are, my z-crits. You want to use a table? Ooh, the table does have a 0.005. You want to use inverse norm? What's inverse norm of 0.005 coming out the big? I'll use this. My table is saying 2.576. Do you all get that?
Yes.
That's from the table. The negative 2.576. That means this would be a 2.576, right? This is negative. That's a negative, that's positive, there it is. Wow, I guess it wouldn't be shading so much, huh? It'd be not much to shade. That's close to, it's getting close to like, I just want to make this picture a little more appropriate. That's really close to the end where it just starts leveling out, right? There's not much in these tails here. I'm shading more for emphasis, right? Negative 2.576 and this. And we're going to get a p-value, true? All right, where do we go? Two prop what? Two prop z-test. Stuff's a blast. Two prop z-test. Best part of the course. By far. By far. I love looking at different proportions. Next class we'll look at different means. Okay. So what do we have? Catholics, 180 out of 560. Capital punishment. Pew Research did this poll, 238 out of 600. Okay. Are the results statistically significant? Which one do I use? Two-tailed. Look for the p-value. But your p-value has to be lower than 1% to reject the null, right? Right, Liz? That's what I'm looking at.
Can you repeat the question?
You bet. So in this problem here, we want to say, oh, you know, are our results statistically significant? We're going to conduct this hypothesis test. I do a nice picture and stuff. We'll get there. We'll get our sample test statistic, this thing, but I always look at that p-value. And we know, right? If our p-value is lower than this, we're rejecting the null. That's what it's all about. Wow, it was close, but we're rejecting the null. Is everyone agree? See it right there? 0.007. Is that less than 1%? Check. Reject null.
So we're not looking at 5, we're looking at 1.
That's right.
Okay.
Very good. The key thing here was when we did this, we can even put this number in here. I think it'd be great, kid. You see that Z right up there, the top one? The negative 2.67? We can put it in our image. It was the sample test statistic, which was negative 2.66. Where is that?
That's not the same thing I
Oh, it's different? Oh, you're the best. Let me go back. What'd you get? Two prop z-test.
It's 580.
Oh, it's 580? Is that M1?
Yeah.
Oh, you're the best. Everyone, I apologize. I put a 560 there. It's 580. How about these numbers? Are those okay?
Yes.
Is 0.001 less than 1%? Yep.
Yeah.
Cool. Hey, I'm going to put this number down. Thanks again for noting that. What's that sample test statistic? Negative 3.09? Where is that? Where would that be? Right there? Someone agree it's right there? So it's in the region. What's our p-value? 0.0019 or 0.002? This is lower than the what? It's lower than the alpha. So what do y'all think? Reject the hoe. There is sufficient evidence suggesting there's a difference in these proportions who favor capital punishment. That right there. Hey, as you're packing up, I do want to point out one important thing. And when I like, this stuff's real life, right? Well, there's another phrase. All day we've been looking at whether or not our results are statistically significant. And when the results are statistically significant, but this is just something I'll hit on next class too. You know what else we should look at? Are the results practically significant? So can I give you an example? Let's say, everyone, we have evidence that we're taking a medication for allergies. Anybody have allergies? Because they're annoying. You take a medicine, but we find out that there's evidence that that drug that you're taking for your allergies actually causes headaches, right?
Yeah.
The results are just statistically significant. Now here we go, okay. Yeah, the results were statistically significant. The p-value is lower than the alpha level. But here's the deal. Are the results practically significant? A lot of times we say no, and you go, why? Because everyone, I'll take the little headache as long as I can kind of breathe during the day, right? What I mean is, I want to take this medicine because it's taking care of my what? My allergies. So while the results were statistically significant, you know, we would say, no, they're not practically significant. Because we'll still use this drug, it's still out there because it does help people out during the day. They can get through their day, they don't mind this tiny headache or the probability likely to have that headache.
So is there also like within 5% range of practical?
That's it, have a great day, yep.
Oh, 5% also?
Yeah.
Ah.